Okay, good day guys, welcome to today's lesson on Python. Today we are going to learn how to program our Python so we can analyze a two-span hinged beam. So in our Python, I'm going to try to get the maximum moment at this span. So we can say this is A, B, C. So the mid-span moment at point A, B, then the maximum hugging moment at moment B, that is this hugging moment, then the mid-span moment at BC. So we are going to try to do that. Okay, so from basic moment distribution or three moment equation, we know that the moment at point B is WL square over 8. Then this we are going to do this, and this WL square over 8, that is on the condition that the L1 and L2 are similar. So in case if they are not similar, then we are going to program it on Python that it gives us the maximum moment. So let's open our Python. So open your PyCharm. Okay, so it takes a little while for it to open. So let's start. Then we start a new project, then give it whatever name you want, choose the environment you want, then create. So let's give a few seconds to create. Okay, so while we wait for it to create, okay, it's almost ready. Okay, so next thing we do now is right click on it, click new, and Python file. So let's give it the name we want. The name we want to give it is two-span, and give it a name .py and enter. So it brings you to this editing place. So now we are there already. So the first thing we are going to define is we are going to define the function. So we can give it the name we want, define. Then let's say we want the name as two-span. Yes. So yes, we can define that. Then the next thing we want to do now is put our W1, that is this W1, which we are going to do. So W1 equals, so we are going to use the float command. So float, then input, then open bracket, then we'll put the text we want it to read. So enter. So let me use capital letter, enter uniformly distributed load AB in kilonewton per meter. So we can see that. Yes, so now we can see we have 4 warnings, 4 errors and 1 warning. So what I'm going to do now is I'm going to shift this. Okay, so sorry, okay, 1 kilonewton. Yes, so I can rename this. Let me just leave it as two-span. Okay, the number, yes. So it's telling me that function name should be in lowercase, so I have to change it to two-span. Okay, the next one, variable W1 is not used. Yes, it's not used yet. Then we have this, it's telling me this point is blank, but we'll get back to it later. So we've defined W1, so let's define W2. Okay, so I can just copy this. Let me copy this, sorry, copy it, command C, come down here and paste. So I just change this to W2, then enter BC, to be in BC, sorry, BC. Okay, so we are done with that. Now the next one I want to define is I want to define my length one, that is the first span, the length of the first span, and I'm also going to define the length of the second span. Okay, so come down here, so I'll just paste it again and change this. Okay, so L1, so I can see the number of warnings I have. I can also come back to fix them. So this one, it must be in lowercase L1. Okay, so enter length, so I can just rename it, enter the length of span AB. Yes, there's no much difference if I use this. I can decide to change it to capital letter, but I'm leaving it, I'm ignoring it that way. So I'll change my unit in meter. Yes, okay, then L2. Okay, I can check this one, W1 not in use. Yes, because I'm not using it. Yes, so when we get to the advanced stage, we get it. So let me copy this, command C, then I press enter, then paste. So I'm going to change it to L2, then span BC. So I'll make it out, span BC. Okay, now I'm going to also define my moment, because I know at this point the moment here is 0, at this point is 0. So I'm just going to assume we have a moment there. I'm going to fix it as 0. So I come here, press enter. So let's see, MA, moment A equals space, then 0. I want it to be equal 0. Moment C equals 0. Yes, so that is the moment at this tip 0, the moment at this tip is 0. So the moment at B, I already told you, from if we have if L1 equals L2, then the moment at B is WL square over 8. So we'll continue in this progress. So now I need to define some functions which I've got my results from moment distribution. So let's start with A naught equals W1, this W1, so we need to use it, W1. You can see now we are using it, the variable asterisk, then open my bracket, because it works with board mass. So I need to get L cube, that is L1 times L1 asterisk L1. Okay, so we've gotten my A naught. Now my A1 is going to be, okay, W2. So I can just copy this and change it to W2 and L2. So that's just it, copy, so paste. So I'm going to change this to W2, L2, since we defined L2. Okay, so my A2 is going to be, so I'm going to explain this when we get there. So my A2 is going to be L1 plus L2, L1 plus L2. Now my A3 is going to be, open bracket, W1 asterisk L1 square. So L1 asterisk L1. Okay, so we're going to divide it by 2. So I'll explain them when we get there. So my A4 is going to be the same thing, but will be W2. So copy, equals, space, paste. So I'm going to change it to W2, L2, L1, 2. Okay, so that's my A4. So my MB now, so I need to get my MB. My moment at B will give me, that is this moment, the hugging moment. The hugging moment at B is going to give me Python. Okay, it's going to give me, so I'm going to open my bracket, it's going to give me A0, that's my A naught, this formula, plus A1 plus A1. So divided by, open under bracket, -8 asterisk A2. Okay, so let me try and explain what it is. So you remember I told you that the moments for my bending moment distribution, I got when I used a value of 1 as W1 and 1 as W2 and 1 as L1 and 1 as L2 for my moment distribution, I got 0.125. so that means WL square over 8. That is what this MB means. So from my analysis, I told you that A0, that is this, plus A1, that is this, divided by 8 asterisk 2, so L1 plus L2. So when we divide this, so we are left with WL square over 8. That is just the simple analysis of what I'm trying to do. So my A100, let me give it A100, is equals to MB. Let me define my MB now. So MB, so we can also check the few errors we have. Let's see the few warnings we have. Sorry, just click it. So it's telling me now that my MA has not been used, but when we move further, I'm going to use that. My MC has not been used because my moment is automatically 0, but when we move further, I'm going to create a formula to make it easy. Now my A3 has not been used. When we move further, we're going to see it. A4, so you can see the ones that have not been used are grayed out. You can see them. So you can see A100 has not been used, and we can see this blank line. So we are going to move all these. So my A100, then the next one I want to create is, let's say, A200. So A200 is going to be, open bracket, A3 minus MA plus MB, so divided by L1, okay. So my A300, so I'll explain this further as we move so I don't waste time. A300 is yes, so I can copy this and Command C, then paste here. Okay, so my A300 is A3 plus MA plus okay, so plus MA minus MB so equals over L1. Then my A400 is A4, open bracket, A4 minus MB plus MC close bracket divided by L2. So then also yes, so my A500 equals, open bracket, A4 plus MB minus MC, so divided by L2. Okay, so we are done with that. So my A600 is going to be A200 asterisk A200, that's A200 square, A200 divided by, so I open my bracket, 2 asterisk W1. So don't worry, when I'm printing out my result, I'll explain all this. 2 by W1, then A700 is equals to, open bracket, A500 square, A500 asterisk A500 divided by 2W2 asterisk W2. Okay, so we are done with that. So now let me start printing my result, because these are the formulas I've used to derive. So I can see I've not used A100, A300, A400, so this is where I'm going to use them now. So we have print, so open bracket, So if I want to print the moment AB now, so I want to print moment AB, so I want it to show me the result of moment, maximum moment at this span, maximum sagging moment at this span. So the formula is print as the moment AB. So I'm going to open my this. I'm telling you that equals A600. So A600 is the maximum moment at that point. So that is the formula. You can see the formula of A600. So that is this times this. So d squared divided by 2 times the load. So if you go back to your analysis, you actually get it. So A600, sorry, A600. Okay, so we've done that. The next one I want to do is print moment B. Print, so open bracket, moment B. So put the semicolon so it can come out. So I'll bring it out, comma, that is going to be my moment B, is going to be my A100. Okay, so we have, sorry, a warning here. So once I click it, it shows me what it's telling me. So I can see I have this issue. Okay, so I'm going to work on it. There's a wrong spelling issue on it, so please, you have to be careful when typing. Okay, so it has gone. Now it's just telling me I'm not still using this, but I'm going to work on this. Okay, so I can give a space here, give another space here at this point. Okay, so the next one I'm going to do now is I'm going to print my moment BC. So I can just copy this and paste. Okay, command C, come down, paste. Okay, so print moment BC. So my moment BC is all going to be moment A700. Yes, A700. Okay, so I'm just deriving some few formulas. Then I'm going to print the shear force at AB, BC. I'm going to print the shear force at AB, BA, BC, and CB. So that's the next thing I'm going to do now. So I can print, open bracket, shear force VAB. So bring this out, come out, comma. So my VAB is going to be A200. So I can just copy this to save time and re-edit it. So command C and click enter, paste. So I'm going to print out shear force VBA. So that is the shear force at this face of the support, the shear force here at this point. Then VBC is at this point. So I hope you understand. So VBA is going to be 300. VBA is going to be 300. Then paste, print shear force VBC. So VBC is going to be 400. VBC is going to be 400.
It's 9 hours.
Paste. So I'm going to print shear force BCB, so which is going to be A500 from the formula I've derived there. Okay. Now, so you can see typo in 2 span. So I can do whatever I want to do there, any edit or anything. So it's telling me I just have only one warning. So it's telling me I have a blank line at this point, so which I'm going to delete. I can delete them. So I'm not using this, I can delete it. So I'm done now. So the next thing I'm going to do is I can decide to run my program to see if it's correct. So come here, then run. So run to span. Okay, so I need to what do you call it, finish the code. So for me to finish the code, I need to put this clause here. Okay, so I just write number let me put in caps lock, number of span equals float. Sorry, it's case sensitive, so float input, then enter number of spans. So enter, let me make it caps lock for this, enter number of spans. Okay, so put my this, then close. Okay, so I can close this. I'm not running this now. Okay, so I have one warning. Okay, no warning yet. Okay, so enter. So if number, okay, sorry, it's case sensitive. If number, yes, this, if this 2, then it's going to run my program. That's what I want it to do. So what's the name of our program? The name of our program is span. So I can just copy this, copy, then paste. So I'm not using this. Okay, so I've told it now. So what in this case I told it to do is, if the number of span is greater than or is equals to 2 span, it should run it, and if it's more than it, it should ignore it. Okay, so you can save this, yes, then run the 2 span. Okay, so now it has told me to enter the number of span, so I say 2. So enter uniformly distributed load of AB. So let's see, I'm assuming 1. So I can still edit this and put it in front, maybe equals to something. Let me adjust it at this point so we can run it. Okay, so let me adjust it here. I forgot to put this in front, so it can look a little bit, yes, and yes. Okay, so let's run. We just have one warning here. I'm going to correct that. So enter the number of span, 2 spans, uniformly distributed load. So I'm assuming 1. I'm also assuming 1. So the span AB, I'm assuming 1, and span DC, I'm assuming 1. So you can see this. My moment AB 0.07, my moment B 0.125. That is WH over 8, and we can see the negative there, so it shows it's hugging. Then moment BC 0 points at this point. Then we have the shear force. So to get the shear force at A is this, the total reaction at B is VBA plus VBC, so give us at CB. So we are done with that. But let's see what happens if I decide I put 3 span. Let's see what happens. So you can see it's not working because I've given you that command. So thank you for watching today's video on Python. Please, if you have any question, you can always drop it down in the comment section, and you can also confirm the results you have with any other software like eTabs or Start Pro or manual method, and let's see if there's any issues. So thank you very much for watching today's video.